Welcome to the Policy Simulation Assistant, an AI-powered prototype that turns open global health data into actionable policy insights. This MVP was built following the ADEPT framework, moving from data exploration to a fully deployed AI product using World Health Organization datasets. Our mission? To help policymakers simulate how changes in workforce and spending can influence life expectancy in just minutes, not weeks. We began by exploring who datasets covering life expectancy, doctor and nurse density, and national health spending. Using ChatGPT and Python under the ADEPT framework, we produced a full exploratory data analysis summarized through an interactive Streamlit dashboard. This dashboard became our analytical cockpit for the 4 analyzed countries: Portugal, Greece, Sweden, and Spain. It includes sections for data overview, showing dataset coverage across countries and years; data quality analysis, visualizing completeness and consistency with an overall quality score of 98.4 out of 100. Then the correlation analysis, revealing that doctor and nurse density have the strongest links with life expectancy; a KPI dashboard highlighting product and technical KPIs; and finally, country analysis, providing valuable data per country. These insights shaped our MVP, a policy simulation assistant that combines data forecasting, benchmarking, and narrative reporting. We generated artifacts in ChatGPT using the ADEPT framework. These artifacts contain rules, information, and guidelines that Cursor can use during the generation of the complete development environment: front-end, back-end, APIs, and documentation. We also used Cursor to generate the 5 features for the policy simulation tool, and we'll show you how. For each feature, we followed this same procedure within Cursor. We told Cursor to make a detailed implementation plan on how to build the feature. This plan contains information such as the business context, technical requirements, and performance targets. Next, we told Cursor to implement the feature following this detailed plan. Cursor read the plan and tried to understand the technical requirements and translate this into actual code. After testing, Cursor will ask us, humans, to perform evaluation before moving on to the next step. Then, Cursor did a code review to ensure that the implementation followed the original plan. It ran tests and checked the code quality. In the last step, Cursor first validated the default tests have been passed, and then updated all the documentation. Finally, it created a push command to GitHub. For the live prototype, we deployed the entire code on GitHub so that we could deploy the backend in Railway and the frontend in Vercel. Because our code is on GitHub, it is accessible for everyone, and with the detailed README file, you can also deploy this locally. We chose Railway because it works well with the APIs that run in the background. Vercel, on the other hand, was chosen because it works very well with the front-end that uses Tailwind CSS. Let's explore it now. The policy simulation engine is our first feature. We start by selecting a country, say Portugal, and adjusting the parameters: doctor density, nurse density, and health spending. When we click Run Simulation, the system instantly returns the predicted life expectancy, the change from the baseline, and the confidence interval, all calculated through our regression model. Here, for instance, a modest 5% increase in health spending predicts a 0.9-year gain in life expectancy, with a 95% confidence interval. Then we move to the health benchmark dashboard. We compare countries, Spain, Sweden, and Portugal across multiple indicators. The benchmark dashboard highlights best performance and anomaly patterns, helping decision makers identify outliers or leaders. In this example, Sweden ranks the best, and we can see their differences in each of the available metrics. Then, on the feature 3, Narrative Insight Generator. After all these steps, the narrative generator turns the data into insights. We can choose the tone, the length, and the audience. For instance, policymakers, formal, and brief. In seconds, the system produces an executive summary with recommendations, key insights, and even a confidence score, ready to export as a PDF policy brief, another feature. We evaluated the system not on accuracy, but on efficiency metrics, showing how much faster and more consistent policy analysis becomes with AI. Compared to manual workflows, we can generate insights 98% faster, with an improvement of 90% on consistency and error rate. The scenario exploration capacity also grew by 100 times, and the latency from data to decision reduced from months to hours, while the cost per insight also fell around 98%. Together, these metrics show how a measurable step change in policy simulation efficiency. From open WHO datasets to a deployed AI-driven simulation assistant, this MVP demonstrates a full end-to-end AI product pipeline, from data discovery and modeling through API integration and UX design to measurable evaluation. The policy simulation assistant is just an MVP, waiting for improvement, but it already proves how generative AI can support ministries, NGOs, and researchers, turning global data into faster, smarter, and evidence-based policy decisions.